in this lecture, we need to use mathematical induction to prove a to the n less than a to the n minus 1 if a is between 0 and 1. We want to prove this one is true for all natural numbers. Means n can choose 1, 2, 3, 4, whatever. Okay? All natural numbers. Yeah. Remember, n start with 1. Natural number means n start with 1. Okay? And 1 minus 1 will be 0. Yeah. N cannot choose 0. Okay? If n choose 0, this is not going to be true. So, starting with 1. 1, 2, 3, 4. Okay, now, before we prove that, we want to understand what's the meaning for that. Why do we need to prove it? Do we really need this in calculus? Okay, that's actually, we really need that. Here is the note before the proof. You know, a here must be in 0 and 1, in this range. You may choose a number a equals 2/3. You may choose 1/4, 1/2, 1/3, 4/5, whatever you like to choose. But you know, here I choose is a 2/3. Okay? After you choose a equals 2/3, you then can look it back, see what's the meaning for that. For example, this n is all natural numbers, then how about we choose another n if n is 4? You may choose 3 to take a look, but I choose 4. Okay? Is what? And then n is 4, here will be 4, and here will be 3. Okay? And since a we already chose is 2/3, so it's called this one, it will be like that. Okay, so this one means that. Yeah, because this exponent is bigger, 1 less than the exponent right here. It means that. Is this really true? It is really true. Even the exponent here is bigger than that. But because this number 2/3 is less than 1, so make it exponent is bigger, the actual value is smaller. It means that. Okay? Why? Again, 2/3 to the 4th is 2/3 cubed times 2/3. That's not the problem, because 1 plus 3 is 4. Now, 2/3 cubed, 2/3 cubed on both sides. Look at that. The left-hand side is this one. The right-hand side, 2/3 cubed, is 2/3 cubed times 1. Okay? And then you see those two are the same. If you divide both sides by 2/3 cubed, they're going to be cancelled. And then 2/3 is actually less than 1. So this is really true. You can also use the calculator to find out. Okay? You can see down here, 2/3 to the 4th, you hit enter is 0.19 something. Okay? But if you do 2/3 cube, it's going to be bigger. You see, what left-hand side is 0.19 something, right-hand side is 0.296 something. Okay? Alright. You know, here I chose n is 4. How about 3? How about 2? So what's the meaning for that? It's basically like the things like this. Okay? If you choose n is you may choose n equals start with 2. Okay? You may also do n start with 1, then 1 minus 1 is 0. A to the 0 is 1. Okay? So you may really do that, but you know, like this. And this one is actually 2/3 to the 0. Okay? and here is 2/3 1. Okay, exponent is 1, so it goes like that. Yeah, exponent is bigger, then the actual value gets smaller. Okay, it means that. It means this sequence actually goes to 0. Or you may write 2/3 to the nth goes to 0 as n gets bigger and bigger. Yeah, that's the actual meaning. For this one, we will see that in calculus. Okay, now let's go to prove this. In general case, we don't want 2/3, we want all the value a between 0 and 1. Now, if this is true for n equals 1, yeah, it is true. Okay, when n is 1, you have what? You have a left-hand side is a to the first, which is a, but we are given a is less than 1. See here? Okay, and then 1 is a to the 0, and then 0 is 1 minus 1, so you have a to the 1 minus 1. So this is true when n equals 1. Okay, you plug in 1 here, and here is a to the 1, and here is a to the 1 minus 1. So it's true, you see, a to the 1 minus 1, and here is a to the first. So this is true for n equals 1. Okay, hence the inequality is true for n equals 1. Then you may do is assume the inequality is true for n equals k, because k, again here, can at least choose 1. Okay? Yeah. Now, keep going. You want to do is that the inequality is going to be true. So, say here, you have this is true for n equals k, so then you replace n with k. So you have a to the k less than a to the k minus 1. We mark this one by a star. You want to prove this is also true for what? For n equals k plus 1. So basically, one needs to show is that when you replace this n with k plus 1, you want this is true. We want to show this is true. We assume this is true. We want to prove this is true. This is not true yet. Okay? We only assume this is true. But from here to here is 1 or 2 steps. You see, first of all, you got to notice again, a is between 0 and 1. That's a very important condition. Look at the example here. Okay, it's between 0 and 1. Then what can we get? What we get is that both sides of the inequality multiplied by a means this star. Okay, of inequality, let me mark star, put it here, okay? Yeah, both sides of the inequality. This inequality means the inequality right here, okay? Yeah, both the sides of the inequality multiplied by a, what do we get? Then, you know, it was a to the k less than a to the k minus 1. If you multiply it by a on both sides, the left-hand side will be 1 plus k. That's a to the k plus 1. The right-hand side is 1 plus k to the negative, 1 plus k minus 1. So you got cancel positive, negative 1, you get that. So from here to here, you just need to multiply it by a on both sides. You will get that. So basically, under this assumption, this is an easy result. But even this is an easy result, you want to say that inequality is then true for n equals k plus 1. Okay, that's important. Because again, this loop never ends. K can at least choose 1. Then through this loop, you have proved the inequality is true for k plus 1. So that means k can choose 2. And then this inequality is true for 1 and 2 go through this loop. Inequality is true for n equals 3. So then n can choose 1, 2, 3, go through this loop again. This inequality is true for n equals 4, because it's always 1 greater than the previous one. Here is k, here is k plus 1. This loop can never end. Then you will say that, therefore, the inequality, this one, is true for all natural numbers. Okay? That's what we needed. Yeah. All right. Please review this lecture. I'll see you next time.